Right, now I want to do a recap from what I was doing last week on eye and the nervous system. Why we learn eye is because eye, right, is one of them that involves your this reflex action that follows that nervous system pathway. Again, let's try. Again, whenever there's any change in your external factors or internal factors, that is always called start with S. Joel? Stimulus. Stimulus is always detected by what, dear? At least tell me. What detects the stimulus? Start R? Receptor. Again, just a quick one. For the receptor that is relevant to the eye, what's the receptor called?
Iris.
你的头啊，懂了。Which is what? Start with in the retina. Which is what? Wait, detect light is what? Start P. You
Photoreceptors.
Yes, photoreceptors. So please remember, photoreceptors of your this retina will actually detect light. So your this receptor, which one is the receptor will always send signals via what neuron? Can you tell me, Jasmine?
Sensory.
So via your this sensory neuron. Question: which is the one that generates the nerve impulses? Is it the sensory neuron or is it your this receptor, Jasmine? Receptor. So I repeat, receptor is always the one that generates, okay, or creates that nerve impulse. Alright, next one. The receptor will always send to the CNS. What is the CNS of the eye? Can you tell me? So your CNS of the eye is my brain. Okay, so the CNS will always contain what kind of neuron? What neuron will the CNS have? From sensory to what? Side R. Relay. Where got relax? You then relax. So again, relay neuron. Always say you send for nerve impulses from sensory to relay. Then what must you always say? Across a? Very good. And then later from your relay to what neuron? Side M. Motor neuron, and you always say is across another synapse. The motor neuron is supposed to send to the effectors, right? Can you tell me what is the effectors, the two main effectors of your eye that's relevant to the eye?
Ciliary muscles and the muscles of the iris.
So again, very good. So it's your iris, alright, as well as your ciliary muscles. Question is, iris is involved in what kind of action? Side B, another word for student is called what? What's another word for
Pupil.
student? Yes, okay, so
reflex.
yes, so again remember the empty space, which is actually a hollow space, that is actually your pupil. Pupil is part of your this iris muscle that involved in pupil reflex. Ciliary muscles are involved in what kind of action? Side A. You go overseas, you want to book room, is also called what? Side A. Oi. Accommodation. Now, ready? Begin yourself. I want to know. So, we already learned. Let's learn the parts of the eye. I want to talk about is your retina first as well, which is your retina. Your retina is actually the one that contains what we see, your photoreceptors, right? But again, I say already, there's a location on the retina that has the highest concentration of photoreceptors. What is it called? Jasmine.
Fovea.
Fovea, spell.
Fovea.
So what's another name for fovea? What spot? 什么颜色?
Yellow.
Yellow spot. So again, I say it's also good to know the type of photoreceptors your fovea has, right? So what's the type of photoreceptors your fovea has that is in highest concentration?
Cones.
Yeah. Highest concentration are cones. Okay, we have another type of photoreceptors, not in your syllabus to know, but at least know they have the highest concentration of cones, which is a type of photoreceptor. Okay, so in other words, any image that is projected onto your this fovea is always the sharpest and the clearest. Clear? Next one, we also have a location on the retina that you can't visualize any image. What is that called? Blind spot. Where's the blind spot located? In front of the, what is this called? Something. No shit. Also something. Everybody know it's something. What is the something? What nerve?
Nothing.
Yes. Okay. Now, can you tell me? This is where the blind spot is, right? So blind spot, there is no image that you will see and visualize on the blind spot. 为什么? Okay, so what does the blind spot have instead? Because it's part of your retina. Of the optic nerve. Again, Joelle, what did she say? Blind spot. How come no image on the blind spot?
No photoreceptors.
Why? Because they have what instead?
They have sensory neurons of the optic nerve.
Very good. Okay, next one. Ready? We also have the effectors. So we know what's the receptor already. The effectors in your syllabus to know is your iris. So this is actually the iris muscles. Iris is involved. That's what you already mentioned. Your this pupil reflex. Okay, come. Let's do a quick one. There are two sets of muscles that is actually part of your iris. What are they?
Radial muscles
And
and
your-
circular muscles.
Okay, can you start with by telling me in dim light what is going to be the effect of your this radial and your this circular muscles? Dim light.
Radial contract
Radial muscles of key what?
of the iris
And
contract.
then
Circular muscles of the iris relax,
so causing the
causing the
diameter
diameter of
What's
the
this?
pupil increase
to allow
to allow more light
to enter the eye. So this is actually your pupil. From the frontal view, hopefully you know this is actually my cornea, right? A quick one, what's so unique about the cornea, Joelle? If I were to point to you, this is my cornea. Two things very unique about the cornea. Oh, my eyes here. So first one, what's the first thing unique about the cornea? Cornea is so that light can pass through.
Transparent.
Transparent, so light can actually pass through. But light also can bend, right? What's the bending of light called?
Refraction.
Refraction. So what enables the refraction of light? What does cornea have to refract light?
Biconvex.
Huh? What are you talking about? Your this cornea has a, like for example, eye and your air have the same density. Do they have the same density? Like air and water have same density? That's why when you see someone in the swimming pool, sometimes you see the body is down here but the head is above, right? Agree. Doesn't look proportional, right? Agree. So what? What is it? Air and your eye have different or same density?
Different.
Different density. Which one is more denser? Is it the eye or the air?
Air.
Huh? You think about this, water and air. Do you see water floating in air? No, right? So again, eye and your this air, which one is denser? Eye is denser, you understand? So what's the keyword we have? This is actually, you flip in front, then you will see. It's actually as, again, a dense medium. Okay? So what's so unique about cornea that I even highlight and even write in capital letters, Joelle?
Denser medium than air.
Huh? Not only write that, I even write capital letters. You know what's caps? Full caps.
Greatest reflection of light.
Greatest refraction of light. Jasmine, name the other three. They also refract light. Yeah? Behind the lens, this is what humor? In front of the lens, this is what humor?
Aqueous.
Oh, this one you know, huh? Then behind is called what? If this is called aqueous. Sabi.
Vitreous.
Spell.
I.
T. R.
E. O.
I'm writing you saying out. Hello. So it's what?
U. S.
Yeah, okay. Please not spell vitreous humor. One more thing that also allows for bending of light or refraction of light. 什么来的? That I also write in green. Draw in green some more. What did I draw in green?
The
Your spectacle also have this.
lens.
Yes. Which has the greatest refraction of light, Jasmine?
Cornea.
Cornea has the greatest refraction of light. What does cornea have, Joelle?
Cornea has a denser medium than air.
Yes. Okay, so take note about that. Now, we have your this pupil reflex. Now you tell me the effects, what happens if you have bright light? Bright light. That's the effect and the response in bright light.
The circular muscles of the iris will contract.
And
The radial muscles of the iris will relax,
causing,
causing the diameter of the pupil to decrease,
allowing,
allowing less light to enter the eye.
eye. Very good. Okay, next one. Ciliary muscles. Ciliary muscles we already learned is involved in Midas accommodation, another type of reflex action, alright? Okay, come, that's it, tell me. I go through the one round. So, 1, 2, 3. Alright, now, whenever I have distant object, what is the stimulus for the distant object?
Object far away.
I know what is very far away. I mean, that's the definition of distant. But I'm asking what is the stimulus? Like the stimulus for bright light is high light intensity. Stimulus for dim light is low light intensity. The stimulus for my this distant object. How am I able to visualize light? Is due to what? Reflected light rays. What happens to the light rays? Is it almost parallel? Or is it diverging? I show you a best way to actually almost parallel. So distant object is almost parallel, detected by what? Dude.
The photoreceptor.
Of the
eye.
okay, iris. No, not photoreceptor. Eye. I want you to specify as retina. Okay, come, Chen Xin, can you now tell me what happens to your ciliary muscles?
Ciliary muscle.
Contract or relax? Contract or relax?
Relax. Pulling the suspensory ligaments.
Oh, you want to say everything? Okay, sure, can. Then ciliary muscles relax, causing. I want to hear the double T.
The suspensory ligaments
To be
tightened and taut.
Tightened and taut, and then what happens to the lens?
Become less biconvex.
So that
Less reflected. Less light is reflected.
to project a clearer image on where? We always try to project where?
Retina.
Huh? No, not just any retina. Are you trying to project also on a blind spot?
Oh.
Then yes, I always want you to specify to project a clear image onto a fovea. Okay, come. Near object. What's the rays?
Diverging.
So rays are diverging, detected by what?
Photoreceptor
Iris, right? Agree. Okay, come. Tell me what happens to the ciliary muscles.
contract
And then causing?
the suspensory ligament to slacken.
Okay, it's pull. And then what happens to my lens?
The lens becomes more biconvex.
So that you will have
Light can be refracted.
to project.
Contract image can be
Yes, okay, so I even went through, right? I think I gave you all a graph, right? You all draw the graph before, okay? So please take note for your this graph. Let's do a quick one. See whether you know. If I were to ask you to draw and focus on the curvature, okay, of my this lens. Let's see, Okay, come. Let's go through. Yeah. Okay, come, let's go through. Starting with you. Can you tell me? No, you sit there. So, again, starting with you. Zitian. A, B, C, D, E. A, B, C, D, E, which one is actually stationary object? A only? Okay, so A and E are your this stationary object. Which one is actually near, which one is actually far? Yeah.
It's nearer.
E is the furthest. No. Then I'm just repeating what you say, I never say it's right or wrong. So which one is near, which one is far? You know what curvature is high, what does it mean? A is near, yes. So this is near object. This is distant object. When I say the curvature is low, isn't this here less curved in that sense, right? Agree? Compared if I were to have a biconvex very curved, right? Agree? So next one, you, Aiden. Can you tell me B, C, and D? Which one? Obviously, all three is actually moving object, right? So B, C, D. Which one is actually moving nearer? Only B is moving nearer. B and D moving nearer. So let's try. This is already near, dude. This is already far, right? So you're moving downwards to the far is moving nearer. I'm mind blown. Are you okay? Zitian already do the heavy labor for you. Which one is near, which one is far? Do you see curvature of lens is actually decreasing? That means, right, it's becoming from what to what? is becoming from this.
Nearer to further.
Do you see? Oh, do you see it's from here and you are becoming like that? Because from more curve, very high curvature to less curve. Oh, you don't just eat the sweet. You answer my question first. So it's what?
Become less biconvex.
So in other words, it's less biconcave, right? Is it moving nearer or further? Further. This one eh?
Closer.
Then this one eh?
Also further.
Yes. So now you know, okay? So this is actually moving further. This is the only one moving nearer. And then this is the moving the furthest. Okay? So know what's the difference? Because sometimes it may actually showcase all this. Okay, now, ready? I'll take a pause. I want to do the homework. Homework, I asked you to do question 10 and 11, right? So let's try to do question 10 and 11 now. Ready? First one. Do you see diagram 1 shows the below shows the diagrammatic section of a human eye? Can I ask, Chen Si, what is X? Where's your worksheet? Okay, can you tell me? What is X pointing to?
The fovea.
What is the Y pointing to?
The blind spot.
And then Z.
Is the optic nerve.
Okay, so the question asks me label where your cornea, ciliary body, iris is. I already showcased to you on the board. Cornea is always labeled here, right? Agree? Your this iris, hopefully you know, is the one that is right in front of the pupil because it controls the size of the pupil. Either why you never do, easier than what Aman, huh? Is it? Why you never do homework? I asked you to do question 10 and 11, right? Agree? So please take note, you'll be helping me later. So again, this is your iris, this is your ciliary muscles. The only one you need to draw is your sclera. Just make sure you know how to label. Sclera is actually here. Okay, class? Okay, but anyway, let's kind of do the questions here behind. So they asked me to state the function of rods and cones. I mentioned before, rods and cones are what? They are part of what? Can you tell me, Aiden? Let me close my dustbin. So rods and cones are what, dude?
Photoreceptors.
So what do they actually do for photoreceptors? At least tell me that.
Under stimulus, they
Detect.
after detecting the stimulus, they produce
No, they detect what first?
light,
So they detect light, understand? And then to generate a
nerve impulse.
very good. But let's learn specifically. So I want my class to at least know these two types of rods and cones. Write down right now. For your rods, functional rods, right? They are photoreceptors. Cones are also photoreceptors. But I'm going to use this question to show you what's the difference between them. Okay? So help me write down. So rods, okay, enable person to detect light. So I repeat, enable person to detect light. While cones enable person to detect spectrum of light and color vision. Okay? So I repeat, cones enable person to detect spectrum of light and color vision. But in exam, usually you can see, right? How come we always want to project onto the fovea? How come we always focus every single light onto my fovea? Because your fovea have the highest concentration of cones. Aiden, what did I say cones are for?
They enable a person to detect the color spectrum of the light.
And therefore color vision, right? Agree? So please take note, use the way, alright? I mentioned before already, Okay, come, Chen Xin, you help me. Do you see we have, again, this label X and Y on diagram 1? So where is my X going to be where the fovea is?
X is going to be the spike of cones.
So the spike of cones. This is why I want you to understand. So where you see the highest peak, where your cones are, which is the dotted lines. This here, you should label that this is X on your this graph for question 10. Okay, Y will be where? Where is going to Y?
The spot where there is no photoreceptors.
Yes. So that's why, please label at this region where there's absence of both cones and rods, that is where your Y is. Okay? Next one, name the parts and X and Y and explain your answer. Joelle, what is X pointing to?
Fovea.
Okay, so what is the purpose of the fovea?
To project the clearest image. Good.
Okay, so again, fovea is because why? Why do you choose that region? The question is asking how come you have to explain. Because fovea always have the,
Highest concentration of cone.
that's what you write for exam, then that would be your 1 mark. Second one is why. Why is what? Jasmine?
Blind spot.
Blind spot. So why you choose this as blind spot? Because blind spot have?
No photoreceptors.
So what does it have instead? Don't just stop there. Sensory of the. Yes, okay, so again, 1 mark, you just need to tell me X is the fovea, as it has the highest concentration of cones. Alright, second one you must mention is Y is your blind spot because it is absent of photoreceptors. Do not stop there, okay? Further elaborate because it contains sensory neurons of the optic nerve. Alright, next one. They say stay and explain what will happen when the light rays strike on position X and Y. So, if light rays strike on the position of X, can you tell me Zitian, will I be able to visualize? Yes, so not only just any image, but the image is always the sharpest and the clearest. And can I also detect the most detailed color vision? Yes, because it has the highest concentration of cones. I want to see all 3 things. Number one, you mentioned is that, okay, it will have the sharpest and clearest image. And color vision is most detailed in bright light at X. 3 things, I repeat, sharpest and clearest image, okay, and color vision is most detailed in bright light at X. Next one, can you tell me, Aiden, how about if light actually strikes on Y?
No image will be produced.
No image will be produced. So all you need is just tell me there is no image, okay, projected on Y. Or
So have the
detected
sharpest
at
and
Y.
clearest image and then
Color vision is the most
vibrant.
detailed, okay? Color image is the most detailed in bright light. Okay? Second thing, you just need to tell me for your Y, no image will be detected, alright? At Y. Next one, Chen-Xin, you help me for this. Sometimes the person cannot see any image temporarily when he enters a dimly lit room. Explain why. Oh shit. Help me cancel this question. You are no longer in syllabus to know. Alright, because you just need to know what are the 2 reflex action. But just a fun fact, usually right, when you enter from a dimly lit room to a brightly lit room, you will have that momentary blindness, alright? Because again, inside your this rods, we have this thing called visual purple, also rhodopsin, okay? So rhodopsin, right, is usually fully bleached, alright, when it's in bright light. But you think about it, when you enter from a brightly lit room into a dimly lit room, at first you cannot see, it's almost like pure darkness, alright? Because time is needed for that visual purple, for the rhodopsin to actually be synthesized in your rods. That is the one that helps you and able to see objects in dim light. Understand? Okay, but anyway, Chen-Xin, can you help me? What is Z pointing to? Is your?
Z is the optic nerve.
So Z is the optic nerve. So what is the purpose of the optic nerve? To send
To send images to...
images. You don't send images.
It
Wrong
sends
terminology.
To send stimulus.
Wrong. What do you always send in your optic nerve? Optic nerve contain what?
Nervous signal. Optic
Nerve impulse. I already say
Oh.
already. Hey, dude, your problem right now, right, is that you always use your wrong terminology. You and Aiden always like to paraphrase or use another synonym for each other. Okay, please take note. It doesn't work that way. Okay, so again, send what kind of signals? What's the signals called?
Send nerve impulse
From the, what's the receptor called?
from retina.
Yes,
to,
photoreceptors or retina to the?
to the CNS, to the brain.
Yes, okay, so that is actually the function. So again, helps send nerve impulses from photoreceptors in the retina to the brain. You must specify. You don't tell me receptors, you don't tell me CNS. You must specify because you already know it's your optic nerve specifically. Okay, come, let's do question 11. So question 11, they say what are the 2 main important structures of the eye that causes changes in thickness of the lens? Okay, so what are they, dear? They will cause changes in thickness of lens?
sensory ligament, ciliary muscle.
Very good. Ciliary muscles and sensory ligaments, these are two structures, 1 mark each. Next one, place the observation. We already went through, right? So let's reiterate. Jasmine, what is going to be the observations? For A is 1, B is 2, C is,
4,
and D is?
3.
Yes. So I repeat, A is 1, B is 2, C is 4, D is 3. You write down already, Aiden? I'll wait for you because you are helping me for the next one.
You can repeat it.
You tell me right now then. You can be able to visualize. Do you see your A? This is thickness of the lens. Same with curvature of the lens here. A and your C are stationary, right?
No, I'm talking about part A.
Part A, you will know the answer what?
I
Also,
didn't know the answer.
what controls the size of your lens?
Ciliary muscles.
And? What's the one in blue? Which is, again, this is so many times. We need to repeat this so many times last week. You forgot again. Start with S.
Sensory.
Suspensory. Oi, abui ho.
Sensory ligaments.
Yeah. Okay. Okay. You will tell me what is missing, ah. Zitian. First one. They asked me to explain what, right? Agree? Notice how the number of marks is 4 marks. Question is, I said already, explain. Okay, Aiden, there's always 2 techniques in doing explain question. One of the 2 techniques, one is your keyword technique, the other one is the overview point technique, right?
I never heard of that before.
I went through this so many times in class. So again, I'll repeat again. Please remember, first of all, do you see this 4 marks here? I repeat, there is only 2 techniques to do this explain question. Number 1 is using the keyword, meaning that we look at, again, how many keywords are there in the question, or actually or how many key structures that we need to talk about. That's how the 4 marks are delegated. The other one is the overview point technique. So my question is, do you see this? Explain your answer. Look there, don't look at me. Look there. So again, explain your answer, 4 marks. Agree? The question will be, which technique will I use so I know how the 4 marks are actually delegated? Do you know what I'm talking about?
No.
Do you know how to delegate the 4 marks then? Why not I ask you, in your own
Explain
terms.
A, B, C, and D.
So do you see this is actually keyword, keyword technique, right? Because again, there is A, B, C, and D, right? Just nice, do you see I can delegate the 4 marks accordingly? Okay, so now, how am I going to explain? First of all, usually what do you explain? Near and far, right?
Yeah.
Okay, so which one are actually stationary objects?
A and C.
A and C are stationary objects because why?
They're not increasing or decreasing, it's just straight.
So again, it's actually a straight horizontal line, right? Okay, what happens actually to the lens at A?
It decreases in thickness.
Huh?
No, it's from A to B.
A is near, right?
Wow.
No, A is near, right?
Yes.
Yeah, why you decrease in thickness? It's horizontal line, ma. Isn't it constant? Okay, so my question is, let's do a recap for you, see whether you recall. Remember I say more, less. That one you recall, at least. So the idea is that we always see an object. Do you need to diminish the size of the object more so you can project an image on retina, or you diminish less? So now I ask you, near object, do you need to diminish more or diminish less so that you can project an image on your retina?
Diminish more.
Diminish more, right? So your lens must be more biconvex or less biconvex?
Less.
More, less. All the more always together, right? So do you need,
Less.
still say less? Okay, do you need to diminish the object even more? So you can project an image on your retina. So this is the size of this water bottle at the back of your retina.
No.
No, right? So do you need to diminish more?
Yes.
Okay, that means you want to refract more light or refract less light.
Less.
But you want to bend light even more, what? So you can diminish the object, what? Bending of light is to diminish the object, what? You know what's refraction or you don't know what's refraction? Refraction of light is what? Is when, oops, sorry. Again, when light actually bends. This is called refraction of light. So usually when there's different density, like your eye and your eye, okay, they have different density, it causes the bending of light. The more refraction of light there is, the more the object will be diminished in size. Does that make sense? That's why I say more, or less, less. Okay, again, before I hyperventilate, can you now tell me, okay, if you actually have a near object, do you need to diminish the object size even more or even less?
Need to use the picture.
Do you diminish more, right?
Yeah.
Do you need to refract more light in order to diminish more, or do you need to refract less light in order to diminish more?
No, less.
What did I say? More. Why do I keep on using the word more? Because they are associated with each other, so you can remember better. So again, do you need to bend light even more to make the object smaller? Why you say no? I already said if you want to bend light, right? The idea for bending light is so that the object can be smaller and smaller and smaller. The more you bend light, the more it becomes smaller. Okay? So that is actually the idea of bending light. If not, why do I bend light in the first place? Like you see, you're this swimming pool, sometimes you see the person's head down here but the body here, right? This is because of what? Refraction of light. So sometimes their body is actually smaller than what they visualize, what you visualize. It's because of refraction of light. So the more refraction of light, isn't it going to be smaller or bigger in size? Smaller in size. So again, if you have a near object, you want to make the object even smaller, would you want, I'm doing backwards right now, do you want to bend light even more? Yes. So when you have more refraction of light, do you want your lens to be more biconvex or less biconvex to bend light even more?
Less.
Oi, hello. More.
More.
Why can't do you know why I keep on saying more? Because they're all associated with each other, like this excretion. You actually secrete more ADH, you have more your this distilled convoluted tubule and collecting duct is more permeable to water. You have more uptake and reabsorption of water. Wasn't that association that you can remember? So if you actually have an object that is near, I want to have more refraction of light. I need my lens to be more biconvex because there's more denser medium inside. Look at the surface area of the volume here, it looks smaller as compared to this. So again, if you have more biconvex, you have more refraction of light, your objects will be diminished in size even more. Hello, help him. You tell me right now. Let's see everybody can get it or not, the rest of you. I want a near object. Near object, what happens to the effect? The lens will become what? More biconvex or less biconvex?
Become more biconvex.
So that the refraction, will you have more refraction of light or less refraction of light?
More refraction.
More refraction of light. So the image is actually more diminished in size or less diminished in size?
More diminished.
More diminished in size to project image onto the fovea. Again, can you tell me for your lens, if I have more biconvex lens, do I actually have more refraction of light or less refraction of light? More refraction of light. So the object will be diminished more in size or less in size? More in size. Next one, can you tell me, distant object, what happens to your lens?
Less biconvex.
Less biconvex. When your lens is less biconvex, what will happen to your this refraction of light?
Less refraction.
So that the object will be more diminished in size or less diminished in size? Less diminished in size. Next one, near object. Can you now tell me, your this lens, what will happen to your lens?
More biconvex.
More biconvex, so that what? You will have
More refraction.
of light, so that the object will become more or less diminished in size? More diminished in size. Next one, distant object, what happens to your ciliary muscles?
The ciliary muscles will contract.
Ciliary muscles will contract.
Relax.
Relax. Okay, so when ciliary muscles relax, what is this called? By the way, what is this? The rubber band represents what on the board? Which structure? Suspensory ligament. So what happens to the pool of suspensory ligaments that I say you write for exam?
Three ligaments tightens and becomes taut.
Tightens and become taut. Lens will become
Lens becomes
less biconvex. When your lens is less biconvex means that there are
less refraction.
less refraction of light, so a clearer image can be projected where?
Fovea.
By the way, the object is less diminished in size or more diminished in size?
Less.
Okay, Aiden, your turn. Near object, what happens to my ciliary muscles? So think about this, that's why I went to ask you the first part so that you know what happened to your ciliary muscles. You can see your ciliary muscles usually must relax I told you this, right? You can use this to go and see, right?
Yeah.
This is called contract. Okay, you release, you do this to your wrist. And you do this to your wrist. Which one has more tension?
Which one?
This one has more tension.
Yeah.
Hello? I say 45 degrees. And then you do like that 90 degrees. No tension at all. 90 degrees. You have tension? How about you? I want to check. Everybody got tension? Got tension? You got tension? Or this one has more tension?
For me, this one got more tension.
What do you do? I never ask you to do all the way to the back. What? I say only relax like that. What? Then later this one is towards, try to pull towards yourself. What?
Funny thing is, actually like this one got more tension. Than
This one more tension. Oh, you all exercise so much, is it? But I do yoga leh. Hello. So again, okay. Why not like that? Don't use that. You tell yourself. You said that this one has more tension. That means you pull all the way back. Then it's what? Just like that, right? And then this one, no tension when you want to try to just bend your wrist without moving
I
your
feel
arm.
more comfortable.
You feel more comfortable.
Yeah.
Oh wow. Okay, I have nothing else to say. Then you have to remember. No choice. Okay, so why not I ask you, in this case, right, what happens to your this lens? Usually, right, ciliary muscles, this one is the only way you remember since you cannot feel any tension. Okay, I cannot help you anymore. Please take note, when it becomes like that, this is when your ciliary muscles actually contract. Tell yourself when your ciliary muscles contract is this motion. Okay? When your ciliary muscles relax is this motion. Which one is when it which one will show suspensory ligaments will tighten and become taut? This one?
Mm-hmm.
Okay, so the ciliary muscles is relaxing or contracting? No.
Relaxing.
I already say already. You have to remember because you already say you're very relaxed. Right? So you no choice. Then you tell yourself it's opposite. So again, you tell me right now. In this case, your ciliary muscle is contracted here. Ciliary muscles are relaxed here. So again, when is your ciliary muscles actually going to pull on your suspensory ligaments? When it's contracted or relaxed?
It's relaxed.
When it's relaxed. And then what happens to your ciliary what happens to your suspensory ligaments when your ciliary muscles is contracted here? What's the opposite for tighten and become taut?
Slacken.
Slacken. Understand? Okay, so please remember from here. Okay, now can you now tell me, if I am near object, so what will happen to your ciliary muscles? Contract or relax? Contract. So what happens to your pull or suspensory ligament?
Maybe it slackens.
And then, what do you describe?
Lens
Lens.
become more biconvex.
So that
more like can be reflected.
So
to
that-
the image
image can be projected on where? Which part of the retina? Even circle?
the fovea.
Fovea. We always try to project on the fovea. Understand? Okay, come. But anyway, so let's try. You will help me right now for A, B, C, D. Okay? So for your this A, can you tell me? Object, how come in this case we choose one as associated to A?
Because the wristwatch would be near the person's eyes, which would cause the thickness of the lens to be higher, right? For arbitrary units to be higher, and because the watch does not move, it will be stationary.
So you need to account for two things, right? Because you already know one mark is for your this A, right? So first one you must account is actually a stationary object. Second one you must account is actually near. Agree? So again, let's hear. Joel, you went to do, right? Can you read out your answer for A first? Jasmine, later it's your turn. Okay? Read out your answer for A. Then I can see and tell you how many marks I can delegate for you. But again, this is using the A, B, C, D. This is how we delegate the marks always accordingly. Okay, what's your A? How do you account for A?
A, the person is looking at something close to them because the lens is thick, making it more biconvex.
That's all? I cannot give you any mark for A because you never talk about, again, a stationary object, okay? And you never mention how come it must be very biconvex or the most biconvex here. Understand? Next one, can you tell me? Jasmine, what do you write for A?
The object is stationary and near, hence the ciliary muscles contract, suspensory ligament relax, having thicker lens.
Okay, so again, you say that one, but please take note, just that you mentioned that it's actually a stationary object, but you did mention, right? Okay, then fine, I can give you 1 mark here. So can you all write for A first, again? So the watch, his wristwatch, number 1, you must mention is a stationary near object. You must mention it's a stationary, then I can give you as well the other half mark, and it's a near object. You don't stop there because explain means elaborate with effort. So for your this lens must be thicker. Why? To refract what, Aiden? Lens must be thicker, more thicker. So what?
To reflect more light.
Refract more light. Okay? So again, lens has to be thicker or becomes thicker to refract more light onto the fovea. Alright? Next one for B. B again is a moving object. So question is, we have used adjectives like decreasing in thickness, or again is moving further or nearer in this case. For B, is it moving further or nearer, Zitian? Further. So if B is actually moving further away, so that's why you choose number 2, right? Agree? So what will happen to the lens? Can I say the lens is actually thick? It's just becoming less, or a decrease in thickness of lens, right? Agree? So why? What's the need for that?
The
Moving object is moving
object is moving
further.
away from the
So lens decrease in,
decrease in thickness. to
okay? Focus image onto the fovea, okay? Or you actually refract less light, alright? To focus image onto the fovea. So, Joelle, do you write anything different for B? Read out there.
B is moving further as the thickness is decreasing. Ciliary muscles relax and suspensory ligaments tighten and become
Taut.
taut.
To refract.
To refract more light on the fovea.
So to refract, yes, to refract less or more light. That's the question.
That's right.
Less light onto the fovea. Very good. Next one, you. What do you write? I'll accept your answer.
Same thing, but I never refract less light.
Again, the idea we always try to refract less light, lesser light onto the fovea. Alright? Okay, so for B, can you write? So you can say object is moving further away, causing ciliary muscles to relax more in order to tighten the pull of the suspensory ligaments. In order to tighten the pull on the suspensory ligaments. For lens to become thinner, to refract less light onto the fovea. For lens to become thinner, to refract less light onto the fovea.
Sure, for suspensory ligaments to
Tighten and tighten. Okay. To cause lens to become thinner in order to refract less light, to project. In order to refract less light onto the fovea. Okay. Next one, for C, we already know it's stationary object. By now, you all should know already. So let's hear your answer. Joelle, what do you write for this? Do you write stationary? Object is stationary?
No, I said that the lens is less thick. So it's less by convex. So that I was looking at something.
So again, it's the same. Then it will be the same as the other one, right? So I still need to mention that it's actually a stationary object. Notice how come I now talk about your ciliary muscles for your B and D is because there's changes in your thickness of the lens. But your ciliary muscles, again, they do not change, alright, between A and C. Alright? So, Jasmine, what do you write?
The omen will be stationary and further than the watch. Hence the thickness of the lens decreases as ciliary muscles.
It's not decreasing already, it's decreasing from the start, right? Agree? So, no. Again, you must still talk about the stationary object. For C, can you help me write down now? Okay. Omen is stationary and furthest away. From his wristwatch, furthest away from his wristwatch. Hence, lens is the thickest. To refract more or less light, Aiden.
refract less light.
When it's thicker, it refracts less light.
More.
more light. So it to refract more light onto the fovea. Okay? So old man is stationary and further away from his wristwatch. Hence, lens is thickest to refract more light onto the fovea. Less light onto the fovea, my bad. To refract less, thickest. Thinnest, my bad. Thinnest, okay, to refract less light onto the fovea. Next one for D, let's ask. D, you can see already, we know is the ball rolling towards him. Okay, so the object is moving nearer. Let's ask, Aiden, when the object is moving nearer, what happens to your ciliary muscles?
Ciliary muscles.
I told you to just remember one, right? The contract, right? Which one is contract?
Ciliary muscles.
Is it contracting? So we use adjective, right? What happens to pull a suspensory ligament?
Become more complex.
Suspensory ligament can never be.
Slacken.
Pull on the suspensory ligament, slacken, please know your English, and then you will say the lens will become,
More complex.
so that
more light can be refracted
to project a clearer image onto the,
onto the fovea.
very good. Okay, so that's why it's the same thing. So you can say the ball is moving nearer. Alright, then all you need to tell me, still need must mention the ciliary muscles. Ciliary muscles are contracting. So use adjective. Ciliary muscles are contracting to slacken the pull on the suspensory ligaments more. For lens to become thicker. For lens to become thicker. To refract more light onto the fovea. To refract more light onto the fovea. Next one, let's look at C before we talk about the diseases related to the eye. So in a bright sunny day, a person will feel strain in the eyes if his eyes are maintained in a condition as that in period A for a long period of time. Explain why is this so. So this is in a bright sunny day, if he actually feels a strain in the eye. So again, Chen Sing, can you tell me whenever you're ready? Bright sunny day, straight away referring to what kind of reflex action? Pupil what? Pupil reflex is controlled by what muscles?
Iris muscles.
Iris muscles. Mainly which muscles will contract in the iris muscles?
Circular.
Circular muscles of the iris will actually contract. Agree? And then not only that, notice how they say he feels strain, right? So why he will feel that strainness in the eye?
I don't know the reason.
Why not? I already said, whenever you're always contracting or you keep on working out, doing your exercise, can you do your exercise for prolonged periods of time? Let's say I ask you to do exercise for 3 hours straight. What do you feel? Muscle strain, right?
Yeah.
Why? Because your muscles are always
Contracted.
contracting. So the perpetual contraction of muscles, right, without relaxation for prolonged periods of time, that is the one that causes you to feel strain. So now I'm asking, so let's ask, he said the first one is the circular muscles will contract. But at A, what other muscles are also contracting? At A, there's also another set of muscles contracting, right? Why is it there? At A, besides ciliary, at A. Start with C as well. Ciliary muscles. You see there are 2 muscles that are contracting. So if the 2 muscles are contracting without relaxing for prolonged periods of time, that's why you feel strain. Okay? Do you write anything different, Joel? No? So you write both that are contracting. So read out there.
I only wrote the radial muscle.
Oh, radial muscles are not contracting.
Yeah, as in, I only wrote the lens become.
Lens?
No.
So off, is it?
No, I wrote about reflection of light.
Oh, then it's wrong. Okay, you, what do you write?
I only write the radial and the circular one.
Then wrong. You? Do you? Okay, never mind. So again, I want to hear 2 things. Number 1, you must say, circular muscles of the iris contracts. So you notice how it's 3 marks. Let's talk about how we actually do this question. This question you should know already. Explain why is this so. If they ask you to explain why is this so, is it use specific keyword technique or the overview point technique? Again, If you look at the number of marks, you should know that this is actually using keyword technique. What are the 2 keywords that we see here? So I know how the 3 marks are actually delegated. So first one, what are the 3 keywords that are in the question? So I know how the 3 marks are delegated. Number 1 is bright sunny day. Number 2 is what? Any idea, Jasmine? What's the second key phrase? So I know how the second mark is delegated. Oh, that was the third mark, but yes, the second one is period A for prolonged periods of time, right? And then the third mark is muscle strain. So now let's see, bright sunny day, how come that is worth 1 mark, Zitian? Because we say of the iris, to increase or diminish the size of the pupil. Okay, then the second one, why period A is also another keyword, Aiden? What do you have to write for period A? What muscles are also contracting? At the same time, what muscles are also contracting at A?
Ciliary muscles.
You just write ciliary muscles or iris contract. For what purpose? To focus? For the lens to be?
More.
Yeah, okay. And then last mark is why strain is because you can say since both muscles are contracting for prolonged periods of time without relaxation, that's why the person will feel strained. Do you see how the 3 marks are delegated accordingly? Always tell yourself, for an explained question, there is either an overview point technique or the keyword technique. This is the next time I say, don't you tell me you never hear of this before. Okay, now, so again, can you write down the first bullet point so you know how the marks are delegated? Number 1, you must mention, circular muscles of the iris are contracted to decrease size of pupil. Do not stop there, elaborate with effort for explain words, okay? Or explain question. So to decrease size of pupil, to allow less light to enter. Second bullet point, whenever you're ready. Is period A. So ciliary muscles are also contracted for lens to be more biconvex. I repeat, ciliary muscles are also contracted for lens to be more biconvex. Last mark is talking about muscle strain. So again, you must mention so many set of muscles are contracting at the same time. So you say since both muscles are contracting without relaxation or without relaxing for prolonged periods of time. I repeat, since both muscles are contracting without relaxing for prolonged periods of time, person will feel strain on his eyes. Notice how I'm giving you in terms of bullet points, so you know how the marks are delegated. Always ask yourself, are you using the keyword technique or the overview point technique? Understand? Okay. Next one, I want to talk about the diseases. What's disease that we need to take note of? Cataracts. Cataracts is one of the diseases. This is why you know, just find some space to actually use your notes. Can you just help me write what is cataracts? Cataracts is when there is clouding, okay, of the lens. So there is pigmentation of this lens. It's white pigmentation, alright? Let me show you a picture how does clouding of the lens actually look like if a person has cataracts. So for this cataract, I'll show you a person with a normal eye, alright? Usually when we look through this eye or your pupil here, what is usually the color of the pupil, Chen Xin?
White. Black.
Oh, white, Oh, black, right? Agree? So actually when you look through the pupil, it's typically black white. Because this lens is clear and transparent, it can pass through. But what are we visualizing that actually appears black?
The cornea.
你的头. No, also start with C. Something cold. The second layer. That is right below your sclera. This one.
Chloride coat.
Chloride coat is usually pigmented black. Why? Oh, I'm looking at you. Ask me. Tell me why. No, ask me. Sorry. Tell me why. Because pigmented black. Why? To prevent internal. Don't listen to him. Sometimes he may be wrong. It's not refraction. It's
Reflect.
make up your mind. So it's what? So to prevent internal reflection of light. Reflection of light is when your light actually bounces. Okay. Why you can prevent? Why the need to prevent? If you never prevent, you will see multiple visions. Alright. Now, however, if you have cataracts, how does people with cataracts actually look like? So I'm going to show you a man. So you can see the man, one of his eye actually has cataracts. Okay. As you can see here, this is actually the eye where the person is cataracts. Do you see appear white? Because I already said when you actually have cataracts, your lens actually is clouded. So less light can actually pass through the lens. That's why it looks like white or appears white as such. Alright? But again, a healthy eye, you can see how it should actually appear black. Because you are trying to look through this healthy lens, your lens is transparent, you're looking at your chloride coat. Understand? So, what is actually the effects for this? Two effects. Number one. First, people with cataracts, first one, vision will actually be blurry. Blurry vision. Sorry about my English. Blurry vision is one. How come I have blurry vision? Reason because, do you see how if your lens is clouded, less light can actually pass through. So in other words, your retina can detect less light. Agree? Next thing is that your color, okay, vision, alright, is actually less detailed or decreases. Color vision is going to decrease. That means the vision or any image is usually appear more faded in color. Reason because you all should know light, right, is also based on color. What? Different color have different wavelengths of light. So imagine, right, if less light can pass through, it's also lesser different wavelengths of light that can pass through and can be detected by your photoreceptors, which is your cones. So that's why please take note about cataracts. But the next thing is, this one is, which is majority of the students here have. Yeah, myopia. So I'm going to teach you two things. I'll draw a healthy eyeball, a one with myopia, and a one with hyperopia. I'll just draw a very exaggerated one. Obviously your eyeball don't look like this, but I'm just purposely drawing exaggerated ones. So this is the one with myopia. Okay, this is the one of a healthy eyeball. Oops, sorry. You can draw your other sticky pad if you want. Okay, and I have one that is hyperopia. Myopia, common term, is actually called short-sightedness. People with short-sightedness means they only can focus and see objects that are near, okay, clearly, but they cannot see distant object very clearly. A lot of distant object is blurry. Agree? Alright? Whereas hyperopia is again long-sightedness. Chinese is the Lao Hua. Okay? So long-sightedness is that you can see distant object very clearly, but near objects not as clear. Alright? Idea is, whenever you have a healthy eye, okay, let's say by right, this is actually healthy. Let's see whether you all recall. 1, 2, 3, 4. First one, there are the 4 structures in the eye that allows for bending of light. What are the 4 structures? Continue. Lens, followed by the 4 structures in the eye that allow for refraction, because I'm going to show how I refract light. Can you please mind your own manners?
I never even do anything. I just.
Okay, but anyway, so it's what? And then what else? Cornea and eventually?
A lens.
讲了. Your favorite? What other humor?
Aqueous.
Aqueous humor. Understand? So idea is that, let's say we have light that actually pass through, alright? By right, they're supposed to focus an image onto the fovea. So do you see the bending of light here? That eventually converge onto my fovea here, okay? So this is my healthy eye, right? Agree? So, however, people with myopia, what happens is that, do you see how usually the eyeball is much more elongated? Idea is that, whenever you cannot see any distant object, do you think the lens can refract more light sufficiently, or cannot refract light enough, or is it actually refracting too much light? I repeat that. So for people with short-sightedness, this is for you, Zitian. For people with short-sightedness, do you think, okay, the lens, okay, can it actually refract sufficient light? Sorry, is it not enough light can be refracted, or is it too much light is refracted? Too much light is actually refracted. Idea is, when you actually have this short-sightedness, when your when your ciliary muscles want to relax. So usually your ciliary muscles must relax so you can stretch this suspensory ligament tight enough, right? Agree? So you can focus on distant object, right? But because of people with myopia, even if the lens want to relax, but again, because of this elongatedness, the pull on the suspensory ligament is not tight enough, such that the lens, right, cannot be less biconvex enough. So that's why you cannot see distant object very clearly. Because, let me just repeat is that ciliary muscles for here not relax enough to pull and tighten on the suspensory ligament sufficiently. So again, I repeat not relaxed enough. So it means that there was too much light refracted. Can you project image onto the fovea? No, no image can be projected on fovea. If you can project a fovea, it should have the sharpest and clearest image already. So if I were to draw, what happens if I'm seeing a distant object? As you can see, for a healthy eye, you can project clearly and converge the light rays onto the fovea, right? But because there was too much light refracted, you can see how an image cannot be projected onto the fovea at all. So it looks something like this. Okay? Clear? How about hyperopia? Hyperopia will differ, right? Please draw. I'll let you all write first. Hyperopia is, again, you can see distant object, but you cannot see near object. Okay? So I'm going to draw what happens if I were to see a near object right now. Again, can you tell me, Aiden, the near object, right? Light rays are diverging or light rays are almost parallel?
Diverging.
So light rays are always diverging, right? So again, I'm going to draw for a healthier person. So if I see a near object, light rays entering the eye are diverging rays. For a healthy eye, usually cornea, lens, vitreous, aqueous humor can actually refract light sufficiently so you can project an image onto the fovea, right? But what happens if you have hyperopia? Hyperopia is that you cannot see near objects, okay? Here, so let me draw the same exact thing. Idea is that if you see actually a near object, alright, there was too much or too little light refracted. In this case, can you take a guess? Too much or too little light can be refracted here.
Too little.
Too little, such that they could not actually bend light sufficiently. You are not refracting into the fovea here. Can you see here? Because there was too little light. Idea is that, because you see how elongated, alright, this eyeball is laterally. So the idea is that usually, right, if you see near object, your this lens must contract, your distillary muscles must contract. Agree? The pull of the suspensory ligaments must be slackened enough. But because it was so elongated, even if the ciliary muscles try to contract, it looks still very tight on the pull of the suspensory ligaments. That's why it became less biconvex, okay? Or not biconvex sufficiently to refract light onto the fovea. So if I were to write down, idea in this case is this time the ciliary muscles not contracted enough to slacken the pull on the suspensory ligaments sufficient. Okay, so is it too much light? No, it's too little light being refracted. Or you can say not refracted enough or sufficiently. So not contracted enough this time, okay? Too little light is being refracted here. Okay, so just now I draw this to compare, because I'm trying to show what happens when you see a distant object and what happens when you see a near object. Okay? Okay, then the next thing is, what will be the treatment for people with myopia? Let's say no money to go LASIK, LASIK very expensive. So, Joel, can you now tell me, what kind of lens will you be wearing in order to treat your myopic condition? You also can see your lens.
Biconvex.
More biconvex? You're more biconvex, but your lens is already too biconvex, right?
Less biconvex.
So idea is you wear not less, what's the opposite of convex? Concave. Okay, so I'm going to showcase what happens. So if you actually have myopia, alright, you are actually wearing, or you are expected to wear a concave lens. Concave means what? Like that lah. This is concave lens. If you look at your lens, right, do you see the concaveness here? Okay, so idea is why? Because you should know convex lens, they refract inwards towards the normal. But concave lens is supposed to refract outwards. That's why, right, whenever you go to, let's say, the optician, right, and they want to check your this degree, right, they are seeing that how much light you want to refract outwards, so that your eyeball, this one you cannot control it, so that your this eyeball can actually refract, okay, your this light back onto your fovea. So this is what is happening. This is a concave lens. Understand? You see it's refracting outwards, okay? Because your this lens had too much refraction of light. So whenever you go to the optician, they see your degree, they are seeing that how much light you want to bend outwards so that your lens can bend all the way towards your fovea. Where's this one? What kind of lens, Jasmine?
Convex.
Yes, convex lens. So idea is, let me just draw. So if you want to draw the lens, right, you will be having is actually having a convex lens. Okay, why? Because there was too little refraction, right? And this is seeing a near object, right? So for a near object, when they actually diverging rays, we are trying to bend light a bit, okay, and then eventually this one can help bend towards further into your fovea. Okay, so to let you know, so this is actually a convex lens. Okay? Oh, I forgot to write, so you can actually write at the top. When I say myopia, that was actually the lens is true biconvex. This one is lens, not biconvex inner. Okay? More, less, okay? Okay, so this is just this lens. Put that aside. I want to do hormones, which is also part of your nervous system. Yeah, quick. Let me pass down, please. So you can see eye and nervous system, how they're related, they already follow this pathway, yeah? Okay? But we also learn, how come we need to learn hormones? Because they're also part of your homeostatic pathway. So I'm going to go through. Ready? Okay, first one is the definition of hormones. I want you to label as 1, 2, 3, 4 for me. From now onwards, if they ever ask you to define hormones, always give me these 4 things for the definition. What's the 4 things? First one, what do you see there, Zitian, for the definition of hormones here?
A chemical substance.
Secreted by what glands?
Produced by endocrine
Endocrine glands. That's your first thing that you always define for hormones. Okay, so again, they are chemical substances. Alright, and you always need to tell me it's secreted by endocrine glands. Now, let's sidetrack a bit. Notice how there are 2 types of glands. One is called endocrine glands, one is called exocrine glands. Chen Xin, what's the difference? What is endocrine glands and what is exocrine? If you were to see your notes I just want to mention for now, endocrine glands means they are glands without a duct. You are not secreting anything via a duct. The opposite from endocrine is called exocrine. Exocrine gland, they have a duct. I give you an example, sweat glands. Sweat glands is secreting sweat via sweat duct. Understand? So endocrine glands is actually ductless. Alright? Whereas your exocrine gland, this is actually have a duct present. Alright? So you will learn this. Now, but that's why, right, we say ethers of Langerhans of your this pancreas is both an endocrine and exocrine gland. So let's try I already say endocrine glands are like, again, anything that secrete hormones, right? So ethers of Langerhans, do they secrete any hormones, Aiden? Islets of Langerhans of the pancreas.
Insulin considered a hormone, then it is.
And one more? Insulin and glucagon. Okay, so when do I secrete insulin? By the way, when your blood glucose level is higher than normal or lower than normal?
Lower.
你的头 higher than normal. That's why again, people not enough insulin can have diabetes, right? And then those that secrete glucagon, when will you secrete glucagon? When blood glucose is higher or lower than normal? Lower than normal. Okay, so again, so ethers of Langerhans, right? Number 1 is an endocrine gland because what do they secrete? Insulin and glucagon directly into what?
blood.
Whereas again, why is ethers of Langerhans, the pancreas, also a exocrine gland? Get ready, I want to know what are the 3 things they have. They secrete what?
Insulin and
No lah, your head must be a duct, right? Via a duct, right? So they secrete what? Pancreatic juice. Okay, via what? What duct is that called? Very simple one. Pancreatic.
duct.
Yeah lah. So again, they secrete pancreatic juice via pancreatic duct. 1, 2, 3. What is the pancreatic juice going to contain? What enzymes? Very simple. Because it's pancreas, then you know the enzyme that always digest your this carbohydrate is called what? Start with A. Okay, so it's first one,
Pancreatic amylase.
Okay, what does it digest? Into? Yeah, correct. Into maltose. By the way, is maltose a reducing sugar? Why you stun like vegetable? Maltose, is it a reducing sugar? Yeah. Yes. Name me the 4 other reducing sugar.
I just know what is not reducing sugar.
Oh, what is not a reducing sugar then?
Sugar.
Okay, then name me the other 4 that are reducing sugars. So she know?
Fructose.
Huh? See me? Hey, you haven't discovered anything. Don't come up with your own invention of words. It's called F-R-U-C. So it's what?
Fructose.
I know your English oral. I very worried now. Fructose. Then what?
The lactose. Glucose.
The other two disaccharides. Maltose and last one, also found in milk.
Calcium.
Calcium.
Why
Bro.
look like talking about that?
Come
It's
on.
like L lah, dear.
Lactose.
Yes. Okay. Now,
Wait.
anyway, back to you. Can you now tell me what's the second enzyme found in pancreatic juice?
Cancer. Wait, shit.
I will have cancer if you tell me. That
Cancer.
So it's what?
Pancreatic.
Something that always digests fat. It's called what?
Lipase.
Yeah. So what does pancreatic lipase digest? Obviously.
It digests your lipids into your 3 fatty acids and 1 glycerol.
No need to specify unless it's just one molecule. So it's fatty acids and glycerol will do. What is the last thing your pancreatic juice will contain?
Pancreatic protease.
Pancreatic protease digest what?
Proteins
Into?
into polysaccharide. And polypeptide. Sorry.
Yeah, okay, can I wipe my sweat? Anyway, moving on. Number 2. So now you know what is endocrine and exocrine. Endocrine, they actually secrete substances directly into the bloodstream. There is no duct involved. Whereas exocrine, they secrete substances via a duct. So your pancreatic juices, right, were secreted via the pancreatic duct into your small intestine, right? Second thing, read out for me. What is your definition of hormones so that you all can label? I always want to see these 4. So it's what? Usually it's worth 2 marks, so you need to vomit out this 4.
Transported via the blood.
So you always must tell me how hormones will be transported via blood. Okay, to what?
To target organ.
So again, can they affect the activity of one or more target organs
Yeah.
in high amounts or small amounts?
Small.
Yes, so again, can affect, okay, activity of one or more target organs in minute amounts. For example, insulin, they affect 2 organs. What are the 2 organs, Jasmine?
Liver.
And?
And muscles.
Yes, good. So, what happens eventually? What's the last one, Jasmine? Read up. Eventually?
Destroy the liver.
Yes. Question is, if you have insulin that perpetually remains in your blood, no good, right? You don't want to decrease your blood glucose to too low levels, right? Question is, why liver can destroy? What is one function of liver? So I'm doing a bit of recap. Elementary canal, your digestion chapter.
Liver.
Yeah, I know. I'm asking you. Why liver can destroy? 你的头啊 liver deaminate, what is it got to do with hormones? Is that liver D like alcohol?
Detoxification.
Yes, they perform detoxification. So again, if you have any hormones that remain in your this blood, alright, it will actually be harmful to your blood. So that's why again, or body, that's why your liver, right, needs to eventually destroy your this hormones. Clear? Clear? Now, that's why, right, every time hormone is secreted, you notice how in your notes on the first column I say cannot have too much of hormone that is secreted or too little hormone that is secreted. I gave you an example, not in your syllabus to know this is just an example. For example, a hormone that we have is called thyroxine. So we cannot have this thyroxine hormone, okay, that is too little in amounts when secreted, because people, right, with too little thyroxine hormone levels, alright, they can develop, for example, in children, mental and physical retardation. Okay, we also, in adults, there will also be very low metabolic rate. So I give you a fun fact, if you all know who Oprah Winfrey is, again, sometimes, right, there was a period of time that she plumped up, right? It's not because she had an unhealthy diet, okay, because she billionaire and then got junk food, no. Okay, it's because, again, she has too little thyroxine secreted. That's why the metabolic activity, right, became very low. That's why people with this, okay, kind of condition, they usually look obese, but they cannot help it. Understand? Another one, you cannot also have too much hormone secreted. I gave you an example. What if you have too much thyroxine? If you have too much thyroxine, again, you have too much metabolic activity. One thing is that your heart can also be too fast, alright? That's a condition called tachycardia, alright? Breathing rate will be too fast. There's a very high chance for organ failure because your organs are always perpetually working at very high levels. So that is just trying to showcase you cannot secrete too much or too little amounts of hormones. But now, in your syllabus to know, insulin, glucagon. We will learn insulin and glucagon at least today. And then I now want to know all the 5 effects of insulin. Just like all the 3 effects of glucagon is expected for you to learn in syllabus. Do you see we have the purple table, double star for me? Okay, now insulin, glucagon.
So you put a thing cell on me.
Put a what?
So this is my okay. So I have a guy at school, right? And every time
Oh,
he
fun
mentions
story time, huh? Okay, come.
somehow
Sure.
like diabetes or like overweight, she will just look at me and be like, huh, I wonder who.
Oh,
And she is taken after him. Everyone in the class is taken after him.
oh, okay.
I'm getting harassed 24/7.
Oh,
I'm getting on the brink of suicide.
That one, I think you need to seek your counselor. I cannot help you. I only can not. Okay,
No.
I sympathize with you. There. I mean, you can prove her wrong. You go through your exercise
I
regime,
go to the
I guess.
freaking gym every day.
Oh,
But I
okay.
don't-
Anyway, then let's move on. Okay, story time over. So please take note, insulin is always secreted when what? What do we always say? When blood glucose is higher or lower than normal?
Above normal.
Above normal. Again, from now onwards, please take note your 3 functions of insulin. 5 functions of insulin. 5 functions are, how I remember, always remember, is 3 increase, 2 decrease. Alright? Why am I giving you so many? Is because in an event, alright, let's say there's a 5-mark question for the function of insulin, at least you know what to write. But the top 2, you all should know already. 1, 2, Transit, what's the first thing that we need to take note about your this insulin? Because you know your blood glucose is higher than normal, no good, right? Agree? So what is the first effect that insulin help to do to lower blood glucose back to normal?
It stimulates liver cells to convert glucose
haven't yet.
excess, huh?
Follow me up.
Increase permeability of liver cells.
And muscle cells to increase.
Uptake of glucose.
Very good. So permeability of muscles and liver cells to increase uptake of glucose or glucose uptake. Let me explain. Remember, the stimulus for this is actually when your blood glucose is higher than normal. Okay? So if I have high blood glucose level, how come increasing permeability helps to lower blood glucose? So if these cells becomes more permeable, there is more glucose uptaken, isn't that lesser glucose inside the blood? So that's why it will also contribute. But we also need to uptake glucose for what? What's the second thing? To increase
Conversion
of
glucose to
right, keyword is what? Highlight the word. It's called
excess.
yes, very good. Conversion of excess. Highlight or underline must write excess glucose to glycogen. Let's do a slight recap. 1, 2, 3, 4. Functions of glycogen as a good storage polysaccharide. It's a storage polysaccharide like starch, right? 1, why?
Increase
Let's hear what you were trying to say. Why glycogen is a good storage polysaccharide? It is very large, so it will not easily
pass through the cell membrane.
so diffuse out the cell. For those who don't know, you better write this at the side. Maybe this can be your side working functions or structure features of good polysaccharide from your glycogen arrow. If you need sticky pad, it's already in front of you. So first of all, she already mentioned it is large, so it will not easily diffuse out of cell. Zijian, what else? Soluble and insoluble in water. Why cannot store glucose? Why must store as glycogen? your this cell, you store high amounts of glucose inside this cell. Good or bad? Why? Because water potential inside will become very, so then more water will move in, the cell can potentially, what? Yes. So, again, for your glycogen, what is so insoluble in water? So you can store in large or small amounts? Large amounts without affecting water potential. That is also the crucial thing. I repeat, number 2, insoluble in water, so hence can store in large amounts without affecting water potential of cell. Okay, come, dude. Eden, what is the next structure feature of glycogen?
Can easily be oxidized into glycogen.
No, not oxidize. Why glycogen oxidize into glycogen? Makes no sense, what?
Glycogen into.
Not oxidize, it's called start H. Hydro.
Nice.
Yes. So can be easily hydrolyzed into glucose for what kind of respiration? Dude. Tissue.
You can say that again. I was writing.
Which one?
No, it's like the one you were about to ask me.
Oh,
you
can
say
easily hydrolyze into your this glucose for what kind of respiration?
aerobic respiration.
Not just aerobic, anaerobic, but also what is the purpose of tissue respiration too?
Release energy.
Very good, energy. Okay, so again, repeat. I repeat, it can be easily hydrolyzed into glucose for tissue respiration to release energy. Last one.
It's tiny, so
Tiny, not tiny. I already say, I already use so. Yes, that's the word I want. So compact in shape, so you can
is stored in large amounts in
within the
tiny space of the cell.
small space of the cell. Okay, so I repeat, is that it is compact in shape, hence can store in large amounts without affecting, large amounts within small space of the cell. Okay? Okay, now, next factor. Joel, what is the third factor that you see is also increasing?
Oxidation of glucose.
Which is also, I said, increase tissue respiration. Okay, come. Joel, tell me what is the word equation for the tissue respiration of aerobic respiration.
Glucose plus oxygen becomes water plus carbon dioxide.
Okay, do you see if I have more tissue respiration, there's less glucose? Agree? But how come I only focus on tissue respiration? How about anaerobic, Joel? Glucose converted to what?
Converted to lactic acid.
Okay, lactic acid, isn't that also help to decrease your glucose level?
Huh?
So that's why increasing tissue respiration, you utilize and use up more glucose. That's why you can help decrease blood glucose level to normal levels. Agree? However, we also have the decrease. Yes? What's the decrease that you see there?
Decrease glycogen breakdown in liver.
Yes. So the idea is if you decrease conversion of glycogen to glucose, isn't that producing lesser glucose? Which will also contribute what? Because if I have this forward reaction, I also can have the backward reaction what? So I need to decrease this. Understand? What's the last decrease that we also see?
Decrease conversion of fats and amino acids to glucose.
Yes. So we also can say decrease oxidation of fats to glucose. You all should know, sometimes let's say you never have a very high carbohydrate diet. Sometimes they say, again, this will help you reduce fat loss, right? Why? Because if not enough glucose, you will instead oxidize fats. But this time when your blood glucose is already very high, you will utilize or oxidize less fat, so you produce less glucose. Understand? Let's get this in our head. Ada, name me the top 2 increase in insulin function. What's the function of insulin? The top 2. And by the way, please help me star this in your notes. 1 and 2. Die, always must write this 2. If it's 1 mark, if it's 2 mark, always write this 2 first.
To convert
Increase her
the ability of the liver cells
and
prevent the
liver and what? I know I don't have, but also is what am I referring to? Like Popeye.
for the muscle.
So liver and muscle cells, why? One must increase permeability. So you can increase, not down, so is what's opposite of down?
Ah,
What's the opposite of down?
Wait.
Oh, I cannot play charades with you.
I'm a bit down. Wait, down. Oh yeah, it's up.
Yes, so to increase what? Our glucose.
Conversion of excess glucose.
Oh my god, why did I go through the. Hey, hello, tell me.
Conversion.
Increase what?
Solubility of muscle.
And?
Liver cells to increase uptake of glucose.
Okay, my eyes here now. What do you just recite? Increase what?
Increase
For-
permeability of muscle and liver cells.
To increase.
Increase uptake of glucose.
Next one, second one, increase. Conversion of? Conversion of?
Conversion of excess glucose into glycogen.
Very good. Next one. Chen Xin, what's your favorite number from 1 to 5?
3.
3. Name me the 3 effects of insulin right now, besides whatever that he has just mentioned.
Increase oxidation of.
Increase.
Eh,
No? What you want? Which one? You want increase or decrease?
increase
Increase. So increase
tissue respiration.
tissue respiration. No else. Decrease what? The backward. Decrease
Decrease.
glycogen.
Breakdown.
Decrease what again?
Glycogen breakdown.
Last one. Decrease oxidation of
Fat.
into.
Glucose.
Yes. Okay. Next one. What's your favorite number? From 1 to 5.
1.
1. Name me the 4 effects of insulin. Name me 4.
It increases permeability of the liver cells and muscle cells
To increase.
to increase uptake of glucose.
And then
It
increase
increase
conversion.
of excess glucose to glycogen.
What else?
It increases oxidation of
Oxidation, not
oxidation
Of
of glucose
during
tissue
tissue.
respiration.
Last one. Decrease. The what? Breakdown.
It decreases the breakdown of glycogen
To-
into glucose.
Last decrease is what?
Increase oxidation.
Oxidation of
fats
into.
glucose.
Okay, name me all the 5 effects of insulin. They chant all for you already so many times. So what's the first one? If she cannot answer, you all will support. So first one is what?
Increase permeability
Of
liver and muscle cells
to increase
uptake of
of. Yes. Next one.
increase conversion of excess glucose to glycogen.
Yes. Increase.
Increase tissue respiration.
Yes. Decrease
Oxidation
Oh,
of
sure.
fats,
of fats into.
glucose.
So there's lesser glucose produced. What else? Decrease.
Increase conversion of glycogen.
Into.
Glucose.
Yes, because you produce less glucose. Round of applause. Okay, now, anyway, please take note, because we study bio, we must study the related disease. The related disease is diabetes. If you flip on the second page of your notes, do you see we have this first column here? I want you to take note, there are 2 types of diabetes you need to understand, and you need to know how to differentiate between both of them. First type of diabetes, please take note, the full name for diabetes is called diabetes mellitus. If the question ever says, what is the medical condition? Then you have to write the full name, diabetes mellitus. Understand? We have type 1 and type 2. Notice how I have type 1. Can you read out for me what type 1 is about, Aiden? So you can highlight in your notes. Type 1 is about the inability. Can the pancreas produce sufficient insulin?
Sufficient insulin.
Sorry?
Ability to produce sufficient.
So it cannot produce sufficient insulin. Understand? So people with type 1 diabetes, they are born with it. So take note about that. Type 2 diabetes, Chen Xin, what do I have there? Notice how I say liver cells are.
Desensitized to insulin.
So do you think that people with type 2 diabetes, can they produce sufficient insulin? Can. So I repeat, type 2 diabetes, right, they can produce sufficient insulin, but the only thing is, you think about this, if you actually have very high carbohydrate diet for prolonged periods of time, you are always perpetually secreting so much insulin all the time. So wouldn't that actually cause your liver cells to eventually be desensitized? It's like I work, I numb already. You know what I mean? Okay, so the liver cells have that kind of concept. Clear? So what do you write in exam? Liver cells, either you tell me you cannot remember the word desensitized, you will write the word no longer responsive. Okay, so I repeat, either you tell me liver cells become desensitized to insulin or no longer responsive. Okay, but we need to take note why insulin is crucial, right? Remember just now I said the amount of insulin secreted is very crucial. We cannot have too much or too little. So let's see what happens if we have lack of insulin secretion. Lack of insulin secretion is what kind of diabetes again, Joelle? In your first page of your notes, do you see? Type 1. So again, in type 1 on the first page of your notes, can you write the lack of insulin? You can write and label at the top, type 1 diabetes. First page up on your 4th column. Okay, so I'm going to explain step by step because I don't have the elaboration down there. So you will write down your elaboration from me. So if I have lack of insulin secretion, do you see the first one I said? Glucose cannot be stored or utilized. So let's ask, Jasmine, what did I say? If you have lack of insulin, your glucose cannot be stored. Why cannot store glucose when you have not enough insulin? Let's ask, what are the top 2 effects of insulin?
Increase vulnerability of muscles
And
liver cells
to increase,
to increase
not down, so is.
uptake of glucose.
What's the second?
Increase
Conversion.
conversion of
X. Keyword?
excess glucose to glycogen.
For storage, right? Do you all see? So, how come you cannot store your glucose? First page. Both of you. Okay, how come you cannot store your glucose when there's lack of insulin? Okay, so you can write at the side, it's because there's less conversion of glucose to glycogen for storage. You're right at the side. Okay, that's why cannot be stored. You not. You write please. Okay, cannot be stored because there's lack of conversion of glucose to glycogen for storage. But the next one I say, why cannot be utilized? Zitian. So I say down there, glucose cannot be stored or utilized. Why cannot be utilized? When is glucose utilized? During?
Exercise.
Huh? No, what is this? Processes of
Aerobic and anaerobic.
respiration. Because do you see, insulin help to increase tissue respiration, right? So you can utilize, right? But if you lack of insulin, will you have this? Oh no! So again, why not utilize? It's because there's lack of insulin for tissue respiration. So that's why you can write at the side. Wow, boys, you all know
What did
You all know what to write or not? I already said it's on the 4th column already. It cannot be stopped. What's the reason? I don't have the elaboration down there on the 4th column.
There's
You know
only
what's
3
fourth?
columns.
There's only 3 columns.
So,
Hello. 1,
1, 2,
2, 3, 4.
Oh,
What the DD are you on?
next one is 3个.
Oh, that is row dear,
Oh,
not column. Oh dear, I very worried about this class, the angmo. Your angmo must be on
Wait,
flick.
check, this one not column.
I already said, okay,
How about
4th
this?
column on your notes. Just
How
look
about
at the
this?
4th column. Do you see the glucose cannot be stopped or utilized, the words that I bold and underline? At the moment. You were specs also no point. You cannot be stopped. Can you write at the side? Okay, because
See how this
lack of
is
insulin to convert glucose to glycogen. And then cannot be utilized is because lack of insulin for increased tissue respiration. Okay. Before I break down, okay, Joel, can you now tell me? Next thing, right? They say muscle cells have no reserves of glycogen. Okay, the body weakness will follow. So the question is, how come if I actually have lack of insulin secretion, I will not have any storage of glycogen? Why? Why no glycogen reserve? I thought the liver and the muscles are supposed to have glycogen as storage polysaccharide.
There's no conversion of excess glucose to glycogen.
Very good. So why body also will weaken?
First,
Lack of?
lack of glucose for tissue respiration. Lack of glucose for tissue respiration.
To
Release energy.
Yes, not enough energy, body weakens. Understand? So why no reserve? Because same thing. Lack of conversion of glucose to glycogen. There was no glycogen storage at all. Because you have lack of insulin, so this one is lacking. Does that make sense? Second thing, why body weakness? So you can say lesser tissue respiration to release energy. So that's why body weakens. Aiden, you meditating? Write down. Do you see the body weakens? Yep. Do you see body weakens? Then at the side, you write there, less or lack of tissue respiration to release energy. for muscle contraction, no? Alright? Oversecretion is also bad. Think about this. If I have oversecretion, alright, you have abnormal decrease in blood glucose, that is for one, alright? Second one, I say shock results. Shock result is because your tissue cells are, again, deprived, or there's lack of, again, glucose for them, supplied to them for tissue respiration, alright? Usually people with this oversecretion of insulin, there are very high chance for them to slip into coma and death if they are not administered with the necessary medical treatment. Okay, so take note. So let's try again. What's type 1 diabetes?
Lack of insulin production.
Yes, by the pancreas. What's type 2 diabetes? Type 2 diabetes is what?
Insulin don't want to work, so
This is the way I ask you to write. Write whose way?
insulin
Write whose
your
way? My way. So what is my way?
Insulin.
What's the one that you see on the second page of the notes that I bold and underline on the first column? First column at the bottom. Liver cells become. Oi, second page of your notes. First column. Now you know what column is, ah?
No longer responsive. No
To?
longer responsive to liver cell.
Liver cell no longer responsive to liver cell. Wow.
No, I said insulin is
Ah.
not responsive to
To?
liver cells.
Do you hear yourself? Do you hear yourself?
Insulin is not responsive to liver cells. Is that wrong? Oh shit, it's wrong. What bacteria am I talking about?
Ah, so it's like, huh? So it's what again?
Oh, delete.
Yeah. Yeah, I think you're having the nervous system, something go haywire.
Schizophrenia.
Is it the sensory neuron or motor neuron or what neuron? Don't know what neuron. So can you tell me what's type 2 diabetes again? Liver cells
This condition may
Become-
become desensitive,
desensitized,
desensitized,
desensitized
to
to
insulin.
yes, can you highlight please so you know your shit? Alright? Okay? Now, so because of this, you need to know what's the treatment for type 1 and type 2. Type 1 diabetes, right? The treatment on the second page of the note, second column. Type 1 diabetes, only you can treat with type 1 diabetes is your insulin injection. Because why? We already established that your your pancreas cannot produce sufficient insulin. So insulin injection is necessary to make sure the insulin levels is of normal levels to perform your this insulin function. But can you actually treat type 2 diabetes with insulin injection, Chen Xin? Can I treat type 2 diabetes with insulin injection? Why cannot?
Because the pancreas is still producing insulin,
Still producing sufficient insulin, but your liver cells are?
not reacting to it.
What is the way that I asked you to write?
They are desensitized
To insulin hormone. What did he say about type 2 diabetes, Aiden? Liver cells are?
Desensitized
To?
liver cell.
Are you
Insulin.
okay?
Insulin. Insulin.
Oh yes, okay. Anyway, moving on. Glucagon. Okay, come. Glucagon has your these three functions. The three functions I want you to learn is all the three increase. Okay? So the first increase, I mentioned this before already. You realize whatever decrease that you memorize for your this insulin is the increase for your this glucagon. Can you help me star the number one function of your this glucagon here? So first function is, do you see I say insulin decrease conversion of glycogen to glucose. So glucagon will actually increase conversion of glycogen to glucose. It is the exact opposite. That's why if you study one, you will study the other already. Be smart in your learning, that means more efficient. Another one you can see increase oxidation of fats to glucose. This is when your blood glucose is below normal. That's why I'm always trying to have processes that produces glucose. Okay? Next one. Can you tell me, Jasmine, what's the third one that you see there?
Increased conversion of lactic acid to glucose.
Yes. And this happens in your liver cell. Okay? Okay, come. Ready? Let's get to it now. 1, 2, 3. First function of your glucagon, sorry.
Increased conversion of glycogen to glucose.
Next one, increase.
Increased oxidation of fats
to last one, increase conversion of
Lactic acid
to.
to glucogen.
Hey, you also reading on the board. You also can read wrongly. Hello. So it's just yes. Okay.
Dyslexia.
Ready?
Yes.
1, 2, 3, 4 lah. Give me 2 functions of insulin.
Increase the permeability of the muscle cells and liver cells to increase uptake of glucose.
Next one, increase
Increase conversion of excess glucose into
to.
glycogen.
Okay, name me 2 other functions of insulin. Jensen?
Insulin increases tissue respiration.
What else? Decrease?
And decreases the conversion of glycogen into glucose.
Oh, very good. Next one. Can you tell me one decrease of insulin and 1 effect of your glucagon? Decrease.
Oxidation of fat and
Into-
amino
Yeah, correct. Into glucose. Next one, the effect for glucagon.
Increase glycogen breakdown.
Yes. Okay. Next one. Name me your 2 functions of glucagon.
Increase conversion of lactic acid to glucose.
And also increase
increase
oxy.
oxidation
of
fats
and into
glucose.
yeah, because you have not enough glucose mah. All the function of glucagon. Increase.
conversion
Mm.
of glycogen to glucose. Increase
Conversion, oxidation
fat
into
glucose.
and then increase
Increase
conversion of
conversion of
the one that is produced during anaerobic respiration
lactic acid to
into
glucose.
yes. Okay, so take note Alright, so this is your effects of glucagon. Clear? Now, do you see the remaining MCQs that you have in your this worksheet?
What?
You know the worksheet that we just did? I want you to complete the remaining MCQs for me now. Except for, can I borrow your worksheet? Let me see. There's one question that I don't need you all to do. I want you to do every single questions on your this MCQs right now, except for what is it? Question 10. Can you help me cancel question 10 and question 12? Help me cancel question 10 and question 12. The rest of them you can actually do. So please do the remaining MCQs right now. And then if I have time, I want to go through. you do 10 and 12, just want to repeat again. Oh, okay. You all done?
Yes.
Quickly, I'll give you 2 minutes. Everybody done? Okay. Jason, later you tell him what's the thing. How many mark class? Then I can go through. Question 1, Denmark. 2, Canada. 3, Australia. 5, Bombay. 6, Canada. 9, Australia. 14, 11 Bombay, 14 Australia, 15 Canada, 17 Canada, 18 Canada, 19 Denmark, 20 Denmark. Can you help me give him the answers, please? Thank you. Okay, the rest of you, let me know if I need to go through question 1 to 3. Anybody from 1 to 3? No? Okay. Question 6.
not B, B. It's B.
2 is Canada. Okay. Question 6 and 9, anybody? No? 5, 6, 9?
A.
No? 11, anybody? 13 to 15? 13. 14. Patients with diabetes mellitus was found to contain poisonous substances called ketones in the urine. What could have happened to the patient? So this is most likely type 1 diabetes. Type 1 diabetes is when you have lack of insulin. So when you have lack of insulin, wouldn't it be again more oxidation of fats and amino acids? When amino acids are oxidized, they form ketones. Ketones by right, if they accumulate, is poisonous to the body. That's why having a keto diet is not necessarily a very healthy diet. Okay, so now let's see. They say patient's body oxidized fats. Nothing to do with fats because the ketones is due to oxidation of amino acids. Okay, they say the blood glucose of the patient drops abnormally low. Again, when it drops abnormally low, that doesn't make sense. What? Because you have lack of insulin secretion. Your blood glucose should be very high. Okay, let's see. C. Patient secretes too much insulin in the bloodstream. Again, when you secrete too much insulin in the bloodstream, isn't that going to have too little conversion of amino acids to ketones? But they are saying that you form more ketones there. Next one, they say patient converts glucose into glycogen excessively. So that's why the only one that I can relate is actually A. You understand? When you oxidize fats or amino acids, you actually form ketones. Okay? So that's why I say sometimes you can just focus on fats. Will do. Next one, 15, anybody? And 17? 19 and 20, anybody? 18, 19, 20? 18 and 20. Let's see. Diagram below shows a transverse section of a spinal cord. Which region allows synapse to take place? Please take note. Remember, synapse is always between your sensory neuron and your relay neuron. And relay and motor. All this takes place in the gray matter, which is inside. Okay? The one that is in that look like butterfly-like shape. Okay? So the answer is only C. Clear? Next one. 20, is it? 20, they say the graph below shows changes in blood glucose in 2 individuals, X and Y. One of them has diabetes. We already know the person with diabetes most likely is X. Why? Because do you see how blood glucose actually decreased over a longer period of time? I want to ask her, Jensen, why do you think that the blood glucose can still decrease? How is this person excreting the glucose then? Yes, you all should know what one sign and symptom for a person with diabetes is that you have glucose in the urine. So that's why it still can decrease, okay? But anyway, we should know that Y is to be a healthy individual. Let's see which cannot be deduced from the graph above. They say A, the blood glucose concentration in X takes longer time to reach its highest peak. Again, can be deduced what? Agree? It takes a longer time, right? About, if I'm not wrong, from your first all the way to your 3rd hour, 2 hours, whereas the other one reached a peak at a shorter period of time. It can be deduced. I cannot eliminate A. Sorry, I cannot choose A, okay? Because it can be deduced. Next one, glucose is converted to glycogen to cause a decrease in blood glucose concentration after 2 hours in the individual. After 2 hours in the individual, it does actually show a decrease one, and that should be the effects of a healthy levels of insulin, right? So I cannot eliminate, I can deduce this B as well. So again, A and B so far is wrong. Let's see C. Individual X may have defective pancreas, cannot produce enough insulin. The thing is that we do not know whether is it type 1 or type 2 diabetes, because there are 2 types of diabetes, right? maybe the X is actually suffering from type 2 diabetes also what? So it cannot be deduced as well. But let's see, because sometimes if an answer we choose, we always like to choose something that is like more correct or more wrong one. So let's see D. They say individual X consumes more food with high content of carbohydrates than Y. Based on this, they already should know between C and D, which one do I rather choose? I rather choose D one. At least C will at least correlate with the graph and the result. But D, they show no information. Agree? Your blood glucose is originally high. Maybe it could be, alright, you already have diabetes, what? It's already higher than normal than a normal person. Agree? So that's why I rather choose D than C.
After you quit high blood sugar.
Okay? Okay, with that, I end off here today. So I introduced to you your hormones. Next thing I see, please bring your list hormones. I'm not complete with it. I'll do hormones, and I feel that I need to do a revision chapter. Anybody says the revision chapter can be... Should I go through? Okay, never mind. I'll decide and let you know. Okay, with that, I end off here today. Sayonara.